Hi there, Mikael here. Let's talk a bit about what is good code and clean code, and what are people or programmer in general saying when they say what is good code and how do we do it. So I have a session about this, and I'm trying to define what people feel to be good code. So let's use this as a starting point to this sort of whole session about good code, clean code. What is it? So, well, let's start with some comic strip here. This is a workflow on how to write good code. And, well, the comic about it is we start up there, we start a project. Should we do things right, or should we do them fast? Okay, we do them fast. Does it work? Okay, we're done. No, we do it well. So we code well. Are we done? Yes. And we go down there. And at the bottom it says, okay, so throw it all out. The requirements has changed. And then we go up again. So I guess the fun part here is that the good code is at the bottom, so we can never ever reach it. So it somehow says to us that reaching good code is a unreachable goal. Could it really be like that? Well, let's move on. This is another fun strip about good code, and it's basically saying that the measurement for knowing what good code is, that would be when someone reads the code, well, how many what the fucks they are saying per minute. And I think I heard one relate to this, that reading bad code, that was like reading a French 1700 novel. Well, he couldn't speak French or read French, and just saying all the way when you were reading this that, okay, what the fuck is happening here? What are they doing here? Well, I can't. Well, wow, what is this? So when you have this sort of exclamation marks when you're reading the code, that is, when you have many of them, that could be an indication of not so good code. And when you are silent and reading the code, maybe that is a good indicator that this is actually good code. So number of what the fox per minute should be a quality item of the whole sort of good or bad code. Should just go like this. There we go. I have a small definition. I made that a couple of years ago, trying to define what is good code. And I did it like this. I said good code is written so it's readable and understandable. Readable, understandable. And it does well what is intended to do. So I prioritized the reading part, that the code is readable and it works. It shouldn't need to work flawlessly or spectacular. It should just work, do what is intended to do. So readable and works. That was my sort of focus when I defined it. So let's have this in our back of our minds when we now move on and see what other people are saying about this good code area. Linus Torvalds is the guy who wrote Linux, the operating system, or the kernel to it at least. And in a in a discussion in Stack Overflow or Stack Exchange, someone stated that he had said like this: he said bad programmers worry about the code. Good programmers worry about data structures and their relationship. So this should imply that Linus thinks that it's more important to work with the data structure and how they relate than to write the actual code. As usual, when we see this type of statements, they are sort of taking out of their original context. And the context where Linus really said this was when he had a discussion and expressed himself about why Git was such good the version software, why that was so successfully. And he sort of discussed around why it was, but he thought one reason could be that the focus was more around the data structures and their relationship than the actual code. And then he sort of comes to the sort of push the conclusion on this, that it's more important to work with the data structures and the relationship than focusing on the code written. So basically he says, just worry about the data structures and the code will follow. In the same discussion, when they talked about this or elaborated on what Linus actually meant around it, it was one comment saying that they sort of they made a comparison to a Roman statesman, Cato, long time ago, you know. And he usually said, if you have the argument clear in your mind, the words will follow naturally. So, and in this comment, he tried to make a comparison then to this statement that if you understand the data structures and the overall design first, the actual code, well, it will follow. So it's not much to sort of think about. This is another same statement in the same area. This is Fred Brooks. He is a writer of the Mythical Man Month, a very popular book on software engineering and how to do it. And he's here saying more or less the same thing, that if you show me the flow charts or the code, and you conceal the data, tables, schema, data structures, well, then I will continue to be mystified about what is your code doing, how does it work. But if you show me the tables, the schema, or the data structures, and well, then I usually won't need the flowcharts or code to understand what is actually happening. So this is another one who's talking to us about the structure of the code. What type of structures do we have and how do they interact with each other? And that is much more important than actually sort of learning how to write the final code in its pieces, because that will just follow. Here is another one. This is also taken basically from the Stack Overflow discussion on what is good and clean code. And this one is Janet Lee. So she should exemplify this example that when we do good code, we should make it look easy. And the relation behind this was this Stack Exchange comment where someone said, okay, I think a good coder is like a good pool player. Okay. Good coder is like a good pool player. Okay. And then he elaborated like this, that when you see a professional pool player, they make it look so easy. And you can sort of almost say, okay, they only got the easy shots. But if you really think about how they are doing, they are sort of, it is not just so putting up the pool stick, hit the white button, go over to the red button, into the hole. So that might be the easy part of it, and you and I can do that. So the harder part comes next, and when the white ball moves on and should be in the position to make the next shot, and the next shot should be as easy as that. And so the example here would then be that, well, they make it look easy, but it is tremendously hard to make the white ball hit one and then move on to the another position for the new shot and do the shot and then move the white ball into position for the next shot. It is really, really hard to do it. So it is hard, but when you succeed, it looks like it's really, really easy to do it. So the metaphor, to bring it to the end then, was a good coder writes code that looks like it was easy and straightforward to do it. So if you are a good coder, your code will look like it was pretty easy to write it. But that takes then tremendously skill and learning to be at that kind of level. So let's remember, try to make it easy. Okay, we'll bring that with us. Here is another one. This is another example on when we discuss on good code and what it is. So this is a statement coming from a judge in the US State Supreme Court, and he said something about like this: I know it, good code, when I see it. So I know it when I see it. It's a sort of statement, and the history behind the statement is a bit learning, educational, I think, at least. So this was a judge, it was in the US Supreme Court, and the judge should sort of state that this movie was characterized as hardcore pornography or not. And the judge was felt unable to do that, and he sort of expressed himself in this area. So he said something. Yes, I will not sort of conclude that this movie is characterized as hardcore pornography. He also said that he could not really relate to characterize what is actually hardcore pornography in this case. So he basically stated it is really hard to say what is and what is not. But they also said, so I know it when I see it. And he also said that this particular movie in the court was not characterized as this. So it's the phrase, I know it when I see it. It is a way when we attempt to categorize one very observable fact or event, but it is so subjective, and it clearly lacks the defined parameters what said that it is or it's not. So that's why I know it when I see it. For sure could relate to good code. It's easy to see the code and say, well, that was good, that was not so good. But it's harder to put up the clearly defined parameters that actually state what is and what is not good code. Perhaps it cannot be done in that way. Okay, so it's a bit hard to define what is this good code. But have we any tip on how to do it? So we talked about Linus, and when he was at the TV show, it was a TED Talk, or he was interviewed. He was asked to show 2 code samples of good and bad code. And he started here with the sort of not so good code example, or the bad code example. Not good taste, he called it. And this is a function. It's removing an entry from a single linked list. And this is what we started with. You see, it's not too many rows. It's less than 10 rows. Have some comments. It's a while loop, and it's an if-else statement. So it's not too much code. And then he said that this is a much better tasting code. And if we try to look at the code, it's okay. So we have one variable at the top. We do some one loop. While loop seems a bit more complicated, maybe. And then we just remove the entry at the bottom. And I don't think it is not the comments that make this code better taste. It is that it's, well, you see, we removed the if-else statement. It's a bit dense, the code, not over complicated. It's so small, so we could focus on the parts to see what it actually is doing. So this is what he called better taste. So let's see, that was not so good taste, and this is better taste. So maybe it's the small things that actually sort of do it. And maybe we need some skills on what is good and bad code. So we need to sort of learn this step by step. Linus also said, which is rather hard to qualify into perhaps, he really wants to work with people that having good taste, and that is being able to write that type of code we saw there, in sort of instinctively knowing what is right and wrong in this sort of code perspective. And well, how should we be able to reach that sort of level of competence and knowledge to have this good taste? Well, we need to start somewhere. And he actually did a good hint here, Linus. And he said, the fewer conditions you test for, the better your code tastes. The fewer conditions you test for, and that is when you tab in, when you have an if else, or when you do a loop. So the fewer conditions, the better code. Okay, well, that is something that we actually can work with. So here we got one step ahead then. Rewrite so special cases goes away and becomes the normal case. And this means remove the sort of decision points and make the normal case. The normal case is not intended. Remove all special cases and try to sort of remove them from your code. And if else statement would be one way of looking at this. It is actually like this, if you haven't heard it before, but it is. We have the static code analyzers or static code linters that sort of processes our code, and they say that this is a bad statement, this is, you could rewrite it, here you're using some bad variable name, or so on. And the linters usually tell us that we do not need an else expression. You know, we have if else, and they're in general trying us to rewrite our code and remove the else expression. The first time you hear that, or when I heard it the first time, I was sort of rather skeptic. Why haven't anyone told me this before? Why should a linter tell me that? Are you a bad linter? So I looked it up, tried to read on the argument why an else statement is not necessary, and then I tried to rewrite my code. All the time I saw my code had an else statement, I tried to imagine the code without it. So it was small parts that I could sort of shift, but I got rid of some decision points, and I actually felt that the code grew on me when I did it like this. So this was, I think this is a very good suggestion to work with, start with. It is the small parts that make the code taste better. And this is not like a black and white world where we should never ever use an else expression. Nothing at all. But it's, if you can remove it, good for you. Do that. And that is actually a small step to the being able to write gooder and cleaner code. So I have a few sort of examples here, code examples that you can take with you when we sort of focus on how should I actually do this. Give me some examples, and here they are. So one example is to simplify the code. So here we have at the top here, we have the one way of doing it. It's a function and it's an if-else statement, which I said we should try to avoid then. And then we have another way here at the bottom. Same function, but written with a ternary operator. So it's basically an if statement, but it's done on one row. And the thing is not, it is more dense, this code. It's smaller. Once you have learned the ternary operator, they are not so hard to read. So it is not that this code looks more complicated. We have basically removed a lot of 1, 2, 3, or 4 code rows or something like that, and got rid of an if-else statement. So it is a bit simpler code. Simplify the code if it can be done. Here is another one. Here is avoid the decision part. We still have this if-else statement here. So return true or false if this is a valid time statement. But this if-else can actually be removed completely and rewritten as a statement instead. So this may be a bit tiny complex statement to read, but it's validating that the time parts is correct, and so it is a valid part, and it will in itself return a true or false value. So one line of row instead of an if-else statement, remove those decision points. Yes, it's a good way to go. It's more dense code without being complicated. Here is another one. Here is the focus on avoiding the else. And we have an if-else statement where we do a lot of code here, in tabbed 20 lines of code, and then we have an else, we'd throw some exception. And when we look at it on the bottom here, we just rewrite the code. So we first check for the error case. And if we have an error case, we throw an exception, and then we come with a normal case. We have the normal code flow, and it is not intended there. So it's the normal case, no intentation. And we're focusing on the normal case and not the special case here. So this is also a sort of a way to reach cleaner code here. Another way to work with the code and make it cleaner would be to generalize stuff. So that we usually can do when we have some kind of object-oriented way of working with it. So at the first example here, we have an animal that could be a dog or could be a cat, and depending on what it is, it does certain things. But as an object-oriented programmer you know that we can generalize these things. And when we do that, we see the other code down here. So we have the animal can eat and make a sound, and we don't care what type of animal it is. So we have generalized the code, and we have ended up with sort of fewer decision points, cleaner code. Here is one more example about code, and we see that this is an assignment, and the first way here is a shop doing discounts, and if we have a discount we should calculate the price one way. If there is no discount, we'll calculate it in another way, and that's a good way to start. Then there's another way here, the middle way, where we try to do it in one arithmetic expression, and we add a ternary operator to check if we should calculate the discount or not. Then we have the third way, that we sort of remove the ternary operator at all. So we have no decision point. We just have one expression calculating with or without the discount. So it's the same, the same arithmetic expression independently on if there was a discount or not. So the last one looks very clean to me. So small things we can do with our code. Of course, we should never forget that the code should work and do what it's expected to do. But when it does that, so maybe we start with an if-else statement up there. And then we see and look at it. Okay, can I rewrite this in any way and making this code a bit more dense, easier to read, remove decision points? And yes, I can. In two ways we see here. So then we do it and we move on with a bit of cleaner code. This is an extracts from an article from a programmer who wrote about good code, and he started like saying that we should start with good enough programs. There is where we sort of we should be happy when we reach that. And good enough program, he said, so they should be correct, not too many bugs. We can live with bugs, but not too many. The program should not be too slow. It can be slow. It doesn't need to be fast. Not too slow. It should work. And it should not consume too many resources. It can consume resources, but not too many. So he's sort of putting up a middle way. It's good enough. It works. Does what intended to do. Let's move on. This is from the same article then. So he sort of stated that good code, that is cheap code that meets our needs. And the cheaper code we can do, the better. And cheap code here is cheap to write. It might be cheap to maintain. It is easy to write. Don't overcomplicate it, make it too complex or focus too much on the code. If it works and it's cheap, move on. We are saying here also that he sort of assumes that the code is just a tool to sort of build the product or so. And he understands that sometimes we want to sort of focus on the tool, the code itself. But most of the time, the overall goal of creating the final application according to the requirements that is so sort of overrides that we cannot sort of be able to have this luxury of focusing on writing really good code. So he's saying, cheap code, do what is intended to do. He is also giving us some hints and tips on how he feel that we can sort of reach this cheap code to his so what he's sort of aiming for. His the first tip would be to keep the code very modular. So organize the code in modules and keep your dependency graph very slim. And a dependency graph is the dependencies between the different modules. And he's sort of saying that a module should not be depending on too many other modules. This dependency should be as sparse as you can. It will sort of reduce communication overhead and general complexity in the software. So be modular, but the modules should not have too many friends to speak to, so they should keep them for themselves. He is also saying that we should sort of relax this external dependencies, bringing in new libraries and extending our code. Is sort of saying that well, he sort of, yes, getting in external tools and libraries might massively reduce the amount of code that we are writing, but they also might have a steep learning curve, and might also increase the maintenance burden of the code and relations with external tools. So we should be a bit chill when we sort of think about taking in these external dependencies. They also have a cost. So maybe don't bring them in, because your code may not be as cheap as you want when you have them. He is also suggesting that we should use fewer concepts. So if your code sort of requires less background knowledge, and the time saved for newcomers to learn the code, since it's easier code with fewer concepts, it's more straightforward. That sort of is a gain and an advantage for this code base. So use fewer concepts. So there is there we have it. All in all over, make your code cheap. And we got a few hints from him on how he thought we should do this cheap code. Good enough programmer. And that is also some essential sort of mindset. Keep it good enough and cheap. Is it something that could be worse than bad code? Well, here, this is taken from an article you see down there, and this is relating to some major strategic failures of large software companies back in the days. And what was common, what they did was they had what they thought was a bad code base, and they made a very eventually they made, or the outcome was that they made a bad decision to throw all that bad code out and rewrite it from scratch. So basically, if you actually have bad code, there might be things that are worse than living with that code and trying to sort of make it small steps, make it sort of re-engineer it to become a better code, because it might be much better to just throw it out and start from scratch. And basically, it's really hard when you have a large code base, start from scratch and sort of imagine that you can do it better the second time. Many times you don't, so you just end up with another half bad code base. So even bad code is not the baddest thing you can sort of live with. There are worse things you can do. I have a comparison here on this bad code and throw it out and rewrite from scratch from two large companies. So it's WordPress and Drupal, and these are both tools to build websites with. And WordPress is not too sort of, well, it is not too good code in it. It's rather bad code, and it's sort of a bit sloppy. But they did a sort of strategic decision that they were going to live with this code, and they were going to have it backward compatible, and they were trying to do other sort of strategies to sort of have this code base live into the future, if you say. And I think they have done it in a very successful way, so it works for them. So they are living with their bad code. Drupal did it in a bit other way. They also had a rather, well, they have a good code base, but sometimes we throw that all out and we go for using another Symfony framework they moved to. And I thought they really, from my perspective, they really strived and had a hard time doing all this, moving their framework to another. Basically, one could imagine that they thought the green was grasser on the neighbor's lawn, but it is not. So it was really hard for them, and I think they lost a few customers during that time period when they were doing that transition. So bad code doesn't need to be as bad as you think. There might be worse things, and rewriting code from scratch could be one of those. This slide is the Zen of Python. It is a 19 set of rules that are sort of giving us some philosophical rules on how should we think about the code and what is good code and what is bad code. So this was written this is PEP 20, so it's a suggestion on how the Python language should evolve itself. And it is 19 rules. The author of it actually left the 20th rule out, so the original Python, the father of Python, should fill it in. He has never done it, so that's why it's 19 here. But we can see them. We should basically read them from top to bottom and sort of think about them. So they say beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. So simple code is better than complex code. Okay, sounds fair. They're saying complex is better than complicated. Okay, so there are levels. Let's try simple. If that doesn't work, try complex. Try to avoid complicated. They say flat is better than nested, and that we have talked about today. Flat is better than nested code. So sparse is better than dense, so fewer code roads is better than a lot of code roads. Readability counts. I told you, readability code, important, and readability counts. They are also saying that special cases aren't special enough to break the rules. So you can't just say, I have a special case. Well, it is not special enough, so you should break these rules. So you see here, there is a lot, we can say it as philosophy, sort of, we are arguing about or talking about what is good and bad in code. But this is actually sort of giving us a set of rules. And these rule sets will then apply to the whole of sort of Python programming community. And this is a rule set they should sort of try to obey when they write their code. And maybe you think that these rule sets are too sort of hard to follow, but when you try to sort of read them and try to think about what they means, and then you use them to put them into context when you write your code, they might be a very helpful guide when you try to relate to your code. So this Zen of Python is an example of software development philosophies, and these are basically advices on how to think and how to do when you code. I have a few examples here, more of these software philosophies. It would be dry, that is, don't repeat yourself. That says, do not do too much copy and paste of your code, so one thing in one place. KISS, it says, keep it simple, stupid. So do it simple, don't overdo it. POGUE is a principle of good enough. Oh, we heard good enough before. So principle of good enough, just do it good enough and then move on. Save your time and put your effort into something else. Yagni, that is about you ain't gonna need it. So it's about doing extra features for the fun of it, and your users will most likely don't use it. So perhaps this is a Yagni feature. It's good to have, but who will use it? Yagni, don't do it. So there are many more of these software development philosophies, and I think I'm going to take a separate occasion to talk a bit more about this, because these are very important tools where you can use when you talk and discuss about your code with yourself or fellow programmers. So yeah, I think this read about what is good code might be a way to move forward from here. So I have a few books, suggestions where you can sort of start to read. So the first one here is it's an older book, but it's quite popular. It's No Silver Bullet. It's a sort of small small stories about software development and what was good and bad in those cases. The Deadline is a rather fun novel about software development. It's a project manager who's sort of kidnapped to a software project where he must succeed, and they sort of discuss and talk about how they are using their code and what happens. So it's a story like, but it's very educational on learning how it actually is when you work in a software project. The Cathedral and the Bazaar is a PDF out there written on some famous people about doing a software project with two different development processes and comparing them. And then we have free books that is sort of usually put up when we're talking about good and clean code. So we have the Pragmatic Programmer, we had Code Complete, and we have Clean Code. Good books that tell stories about programmers talking with about what is and what is not good code. And we need sort of to fill ourselves with a few of this knowledge to be able to sort of relate to the code we have. I think this is one good way to start a journey on sort of becoming a very good programmer and write good code. We need to read about it. This is one statement from the book on the No Silver Bullet, and it's basically saying something. It's a popular quote from it, and it's basically saying that there is actually the stuff we are doing. There is actually no tool, no process, no way of working, no technology that will ever make us tenfolded improvement in productivity or quality. So there is no silver bullet to the things we are doing. So you can't sort of be 10 times as productive just by changing to another process or another programming language. So it is a bit hard, so you need to take these small steps forward, and you shouldn't rely on some magic of the silver bullet just sort of making it all happen. So there we go. Should we try to sum this up a bit? And Mikael has the slimmest suggestion ever. You should talk to the duck. When you have sort of read one of this book, and when you're trying to learn and study the software philosophies, you should also sort of, you need someone to talk to. So talk to your friends. You should talk about a lot about code. But when you are alone, you should have someone to talk or discuss your code decisions. So use the duck. So it's the basic idea is it's a rubber duck sitting on your end of your keyboard there. And basically when you're trying to make a decision, or when you know there are several paths to go and you want to know what is right, well, then you formulate this question, and you could put it out loud. Talk to the duck and ask him or her the question you're sort of thinking of. And the magic behind that is when you are formulating that question, and that is very good start there. Formulate the question. And when you hear it out loud, you will very, very often be able to sort of reply to the question yourself. So it's basically a way of thinking. And you can do this with software philosophies and trying to reach good code or working code. And this is also coming from sort of rubber duck debugging, if you have heard the concept before. That is when you're sort of you're trying to debug your code and you sort of get stuck. Then you take up your duck and you ask it, well, you don't ask it, what should I do next? No, you should try to formulate the question that is most important at the current stage. And you ask the question to the duck, and then you most likely will be able to answer it yourself. So, if you don't have a friend, talk to the duck and discuss development philosophies with it. I will try to wrap this up, and I'll do it with some kind of scientific definition of what good code is. This is well, pseudo-scientific. It's an interview of 65 developers, and they were trying to categorize what is good code for you. And so they just did a survey, and the result came up like this. On the top there, we have sort of the smallest. These are not so essential. This bunch of programmers thought. On the bottom here, then with the largest staple, we see, well, these feels to be important. So the bottom there, almost 80% of the developers stated that this is an important characteristics for good code. And it's saying readable code. Okay, have we heard that before today? Of course we have. Readable code. So very many programmers out there say that readable code is a very important feature of good and clean code. They're also saying that testable code is. So that was the almost 30% says testable code is very essential for sort of driver for good code. And we know a bit about testable code, and we also know that when the code is testable, it is usually written in a manner that sort of actually could exemplify, well, this is good code. Good code is usually easier to test. So we have readable, we have testable. They also said simple. They said simple code. Have we heard that before? Make it look easy, or it should be cheap code. Yes, simple. They say it works, just works. Not overdo it or work in a flawless manner. Work. The code should work. And yes, we have heard that also today. Having not, it's a good enough program, should work. Should be maintainable, easy to maintain, and yes, I guess it will be if it's readable and if it is testable. And they wanted to have some kind of documentation with it. So these are the sort of the top characteristics from this small scientific definition survey of what is good and clean code. Readable, testable, simple, works, maintainable, and documented. So there we have some sort of hints on how could we work with our code to be able to reach a bit more of this sort of good and clean code part. So, a few minutes later, we come back to Mikael's definition of what is good code. So Mikael said, good code is written so it's readable, understandable, and does well what is intended to do. Okay, so I think I'm going to stick with that definition. And you have seen here, so we talked a bit about what is good code, what different people think. They have different kind of statements around it. partly philosophic statements. It's not sort of, they can't really get a good grasp of it. They talk about good taste and bad taste. They say that, well, I know it when I see it. So it's very loose-ended. But maybe if we start to read about it, we sort of can get some grips and sort of hints on what it actually means. But don't forget, we also saw a few code examples where we sort of related between good and bad code. So we got some hints on how we should actually be able to produce it. So I'm going to stick with this definition for my sake. Good code is written so it's readable and understandable. I can read it. It's easy. And it does well what it's intended to do. It works. Good enough. So that's the end of today, and we have talked a bit about this concept of good and clean code. We could not, like the judge, make a sort of definition on what it is. It is sort of too hard to do that. But when I see it, I will know if it is good code or not so good code. So I hope you enjoyed, and I hope that you got some feeling on the concept of good and clean code, and maybe how you could be able to progress from here and work with the concept. Read, talk, discuss, relate to software philosophies, and we also saw some examples of the code, and start by removing your else statement, perhaps. That is a good way of just getting into it. Okay? So thank you for today, and have a good one, and I will see you shortly in another place. Bye bye!